How's it going? How many of you are done with the first part A? Okay. Part B? Part C? Okay. I'll give you like another minute and a half. Yeah, you can ask a question. Yes.
So, if it turns out to be a fraction, do we keep that as a fraction?
If it reduces, just reduce it. So like is that a 3 on the bottom? Or?
No, it's a 5.
Oh yeah, then just leave it like that.
Okay.
Yep. Just write it as a point. With the 0 in there. That's what I mean. 0 and then negative 12 over 5.
Okay, but then how do you graph that?
Yeah, so what is that? That's a good question. So why don't you just get your calculator out and do that, negative 12 over 5. You get negative 2.4. So, 1, 2, 3. Is that your x or y intercept? Y? Okay, so 1, 2, 4. So like negative 2.4, somewhere around there. So you're going to be estimating it, okay? Yeah.
Is it okay if I graph it on my calculator after I get to my y equals? Yeah. If I know how.
What do you mean graph it? Just to check that you're doing it right?
Once I get to this point right here, I just put it into my y equals.
Okay. And what about the x-intercepts and y-intercepts?
I know how to trace it.
Okay. I'm going to want a fractional answer.
Okay.
You know what I'm saying? I want to see the work of this, of you getting the x-intercept by plugging in y equals 0.
Okay.
You getting the y-intercept by plugging x equals 0. Yeah.
That's
This
one of
you
the
can check your work.
downfalls of taking this class. But see,
So you got
we
all
had
these
to,
different
in
methods.
my college algebra class, we had no choice but to use
it, yeah.
graph everything. We
Yeah.
didn't even.
Yeah. This we're just more about the mechanics of it, because you can use that to.
So use it to check it.
Yes, I would. Yeah, I mean that might slow you down a little bit, but it's good to verify it.
How would we graph negative 12 over 5?
Just the way you just did it right there. Just estimate it.
Okay.
Yeah.
Turn it into a decimal.
2.4. Yeah. Go to a decimal. Yeah. Okay, I think it's time to talk about these. Are y'all ready to talk about these? All right, I'd like for you to grade your own paper. You're going to put a grade at the top of your quiz, all right? All right, so for the first one, we're going to do this just by if we have a majority of people who agree. So for the first one, what is the slope? 1? 1/2? 1/2? Show of hands? Yes, okay. What is the x-intercept? Negative 4, 0. We're all good?
Do you want us to write it like that, or do you just
Like this. Yep, as a point. What is the y-intercept? 0, 2. Everyone on board? And then the graph of that one would be, well, I could just do it off the intercepts. Negative 4, 0. So watch the way I write this. I'm going to put negative 4, 0 here, so everyone knows that's the point there. And 0, 2, I'm going to label it 0, 2, like that. And then I'm going to draw a pretty good straight line through there. All right? That would be for part A. Part B. What do you got? Negative 1/8. Everyone on board with that? X-intercept. 8, 0. And y-intercept? 0, 1. Do we have a majority there? Okay. So to graph that one, let me just put that one on the same graph 8, 0, 1, 2, 3, 4, 5, 6, 7, 8, 0, that's here. And then 0, 1 would be here. And then I draw a straight line through there. Whoa, whoa, whoa. All right, close enough. All right, I think the last one was the trickiest one. What do you get for slope on the last one? Negative 3/5. X-intercept? Negative 4, 0. And y-intercept? 0, negative 12/5, something like that? Okay, that's it. Now, the question is, how do you graph this? So I'm going to go to negative 4, 0, which is still this point right here. But this point, I'm going to need to know where that is, so I'm just going to get on my calculator and figure that out as a decimal. I'm going to do, 12 divided by 5. I'm going to get negative 2.4. So that means I just need to go down. Here's 1, here's 2, here's 3. 2.4 is almost 2.5, so it's just going to be estimating, right? But I'm going to label it so everyone knows what it is, and then I'm going to draw my line through there. We good? Now, if you had any trouble getting any of these, go to the lab. Do you all know? I know some students didn't know or didn't quite hear me clearly on the first day. We have a free tutoring lab right across the hall here, room 316, and you can go in there and get help. I know sometimes my times that I'm available it doesn't work for you, so I think they're there Monday through Thursday. So, and they have pretty good hours. I think they're there 8 in the morning, think till like 8 or 9 at night. So, all right, we're good. Okay, so I want you to give yourself just your own honest grade. What you feel you deserve on that. I'm not going to hold it against you if you give yourself 100 and everything was wrong. But then you'd be lying to yourself and, Okay, so let's please hold on to those. I want you to hold on to those. And I'm going to collect those tomorrow, right? So bring those tomorrow and use them to review, study if you want. All right, so look at this. This is kind of an interesting problem. What if I gave you the same instructions here? Find the slope, x-intercept, y-intercept, graph. And I gave you negative 4x plus y equals 0. So for slope, you solve for y, right? And you get y equals 4x. So the slope would be 4. Okay, how about the x-intercept? You set y to 0, and that would give you negative 4x equals 0, and you divide both sides by negative 4, and you get, what is that? What's 0 divided by negative 4? 0. So as a point, it would be the point what? The origin, 0, 0. What about y-intercept? Set x to 0 and you get what? Y equals 0. And so you'd have the point, what, 0, 0 again at the origin? Y'all follow that? Now, if you were asked to sketch this, what we've been doing in the past, the x and the y-intercept together was enough to be able to draw it, right? But notice that the x and the y-intercept are actually the same point, aren't they? So now you don't have a second point to go to, do you? So how could we get this line from here? How could we? We could use the slope, couldn't we? We could use the slope and we could go, what the slope is 4, which is 4 over 1. So we could go up 4 over 1, right? Fine, we could do that, great. But let's think about it a different way. If this is the equation of the line, I could pick any value I want for x right now, couldn't I? And it would give me a value of y. So let's pick something that's not trivial. Let's pick something like, I don't know, 2. What if I plugged in 2 for x? What would I get? 2 for x, it would spit out what? 8. So I go out 2, up 8. And that would give me a second point, right? And I could draw the line. I could have also plugged in 1 and it would have spit out 4, and that would have got me right here, which is the same as going up 4 over 1, right? So the point of this problem is just to show you that, hey, sometimes your x-intercept and y-intercept are the same, which means having those two pieces of information is not quite enough to get the line. You have to either resort to going to the slope to get it, or you have to just plug in your own point, your own value of x, and spit out y and plot that point and draw. All right. It's 2. So I think that's probably as far as we'll go. There's another section on applications of linear functions where it's a bunch of word problems. And what I think I'll do is I'm going to put that on the next test. Okay? That way, I think this is a good point to say, all right, that's all the material that'll be on this test. And we'll pick up the other stuff next time. And we're going to talk about the exam now. But I did want to talk about division by 0. I know you said you didn't want to see it, but
Well, I'd love to, but more time on the test would be awesome.
yeah, I understand. I'm not going to put this on the test or anything. Okay? So let's see. If I write the fraction 1/2, I think most of us would agree that that means you have, like, let's say a pizza, and you're taking half of it, right? If I write 3/4, then if I start with a pizza, I'm going to take this and cut it up into how many pieces? 4 pieces, 4 equal pieces, and I'm going to take 3 of the 4, right? This is kind of when you're first learning about fractions, this is what they're telling you. So what if I take the number 1? That's the whole thing, isn't it? Because that's 1 out of 1. So what you're doing is you're saying, all right, take this whole thing and cut it into 1 piece, which means it is 1 piece, right? That's 1 piece. And take 1 of those 1 pieces and you have 1 pizza. So you're taking the whole thing. If I write 3, that's not 3, that's 2. That's the same as 2 over 1, so that means I'm going to take this whole thing, I'm going to make 1 piece out of it, which it already is, and I'm going to take 2 of those. So 2 of those whole pieces would give me 2 pizzas. Yes? What if I write 0 over 4? That means I'm going to have my pizza cut into how many pieces? 4 pieces, and I'm going to take how many of them? None of them. So I'm going to have nothing, right? That's why 0 over 4 is 0. If I take 0 over 8, take your pizza, cut it into 8 pieces, and take how many? None of them. So you're still going to have nothing, right? Making sense? All right, now let's try the division by 0. So what if I write 2 over 0? Start with nothing and take 2. That doesn't make any sense, right? Because in all of these fractions, we've assumed that we've started with something. We've either cut it into pieces or we've left it alone, right? But to write this means we want to take two pieces from nothing. And I know you might be saying, well, wait a minute, that should just be nothing, right? Because you're taking 2 from nothing, you can't do it, it's nothing. Well, the problem is that we can't start with this and say we're going to make 0 pieces out of something. It's 1 piece automatically. If that makes any sense. That's one kind of reason why it doesn't make sense with fractions to have division by 0. It's implied that there's 1 there to start. All right, what about the exam? So I was looking, I found some tests that other instructors had made. I looked at some of the old stuff that I had, and I didn't like any of it, okay? Because the packets changed a little bit over the last year or two. So the way that I'm going to make the exam is as follows, all right? And this is what I recommend you do to prepare. I'm going to go to each homework section. So I'm going to start like with homework fractions, right? And there's, about what, 16 problems? That's how many I have for mine. Part A. Part A. There's like 16 problems. So I'll probably pick like 2 or 3 of those. Those are ones where you have to add, subtract, multiply, divide. So I'll make sure you know how to at least subtract 2 fractions, and then I'll probably ask you to divide, because if you can do division, that means you have to do multiplication. So 2 problems from there. And then I'll get into the application problems, which are the word problems, part B. And I'll look at those, and when it comes to word problems, I'll probably pick 1 or 2 tops. Right? That's what I'll do. Now, I'm not going to pick exactly these problems, all right? But I'm going to act like I'm making the test. I circled number 4 for myself. I'm going to make a problem like number 4. So I'll probably do something like 8 2/3 minus 4 5/6. There we go. There's the problem. That would be a problem I would make on the test. And that matches up exactly with number 4. Make sense? And I'm going to do that for each homework section all the way up through characteristics of linear functions, of graphs of linear functions. Now, I know you want me to give you a review where I hand it out and you're like, okay, here, I'll just practice that review. My review for you is to go back and just review your homework. Make sure that you understand how to do all the problems. And let me see here. How many problems will there be on the test, approximately? So from homework on fractions, there's probably going to be like, let's say, 4 problems. On homework for order of operations, I see another 4 to 5. So let's keep track of this. I'm at what? About 9, let's say. For operations with polynomials and applications, 2, 3, probably 3, so we're up to 12. Percent, 2, 3, maybe 6 problems out of that. You're gonna have some word problems for percent proportion. I'd expect 3 to 4 word problems for percent proportion. All right, scientific notation and conversions. I would expect probably another 6 problems from there. So what are we at now? 24. 24? That's a lot. And then for lines, just the section on lines, probably 2 to 3. Characteristics, 2 to 3. So 30 problems? Somewhere around 30 problems.
On the conversions, are you going to do the application problems too for those?
Yes, if it's in the homework, it's fair game, yes. Yeah. I know conversions are probably one of the most challenging sections for a lot of you. I understand that. But just, do what you can to prepare for it and see how it goes. Yes?
Are we going to have the entire class?
Here's what I'll do. I'll make the test, and then I'll take the test. And usually for a class like this, I'll take how long it took me multiplied by 5 or 6, and that's how much time I will give you. So It should take you 5 to 6 times the amount of time that it takes me. That's my rule of thumb in a class like this.
So what's your projected amount?
I don't know. I need to see how long it's going to take me. Here's what I'll say. If that time comes out to be the whole class, then I'll give you the whole class. But if it turns out to be like, you know, I could do it in 15 minutes, then 15 times 5 or 6. So I think you'll have a lot of the time. But I will also make sure that it's not too long. You know, like I'll make sure that when I multiply by 5, it's not like 7 hours long or something like that. Any other questions? I'm actually probably going to cut a little short today just so you can go to the lab and study, because I know that's what you're all wanting to do.
So after the exam, are we going to be covering any other topics?
No, the exam is the only thing we will do next class. So it's the exam, then you're free to go. As soon as you're done, you may leave. Bring all your homework with you. Bring all your homework with you that you've been doing up to this point.
So what would happen if you're not done by the time we said that we have to be done?
Okay, so if you run out of time, if you use the whole 2 hours, the exam will end and you'll have to turn in what you have, because people may have other commitments. You know, maybe that you can stay for another 2 hours, but someone else can't. They have to be somewhere. So to be fair, time will be up, and then if it comes to that, I'll look. You know, did half the class not finish? You know, we'll see. What's that? Yeah, do the homework. For tonight, the homework is everything up through characteristics of linear functions. What's that?